Hello friends, good evening to everyone. Welcome to Unacademy, which is the largest online education platform for GATE, Computer Science and IT. Here myself, Malesham Devasani. I'm going to take the classes for Theory of Computation, Compiler Design and C Programming on this YouTube channel. Here today we are going to see a very important session in Theory of Computation, and also this is one of the topic in discrete mathematics, countability. And in this countability we are going to see countable languages and uncountable languages, and what is the relation between decidable and countability languages, and all these things we are going to see in this session today. So before beginning today's session, as usual, let me introduce, if anybody is attending today's first time, please let me introduce myself as well as things that we do on Unacademy. Yeah, good evening, Satyajit. Yeah, on year rank 119 and 210 in my BTech final year and third year respectively. So this I have secured with the self preparation. So that time I used to prepare textbooks and I had vision. So I'm trying to help you how you can understand the concepts for various topics in the C programming. And later I have completed MTech from IIT Bombay, then started taking the classes for GATE, and I have experience in various subjects like TOC, Compiler and so on. DEVALIVE is my referral code. Anyone at any time you are interested for taking the plus subscription, use DEVALIVE as the referral code to, as well as you will get guidance from me. And the thing is, you require to join Unacademy. So here, if you look at Unacademy, gives you the free classes to understand how educators teaches on Unacademy, and what we teach, how do we teach is visible to you, and you can attend our classes before taking the subscription. And once you are ready for plus subscription, if you are ready for plus subscription, you can take the subscription, but benefits are like every subject you will have a practice session, every subject you will have a regular course, every subject you will have a revision course, every subject you will have a GATE course, and every doubt clearing course. So this many courses are designed for learning one small subject. So if there is a lot of scope to understand every concept clearly. And these are the benefits on Plus platform, that is, you will have a live classes, crash courses, as well as weekly tests, doubt clearing sessions, and you will have classes in both English and Hindi, so you can ask the doubt in both languages. You will have a revision rank improvement batches, and apart from that is another subscription plan, Iconic. In Iconic, all the benefits of the Plus are available. Additionally, you will have one-to-one guidance, you will have a study plan to prepare exam, and you will have booster sessions, and you will also have a personalized test analysis, and you will have a separate material to prepare. These are the plans we have. Main plans that are 1 year, 1.5 year, 2 year plus subscription. And choose GATE and ESE, and either you choose Plus or Iconic. If you go for Plus, you can choose any as per your requirement, and we always recommend to go for 2 years if you are in second year, third year. In final year, if you are there, then 1 year, 1.5 year, and 27,225 for 1 year, but apply the code DEVALIVE. Similarly, you have other plans too. And Iconic subscription is more beneficial if you are looking for guidance, if you are looking for separate material, if you are looking for the booster sessions. And 1 year, 2 year plans are very popular. Apply the DEVALIVE code and you will see the amount 45,225 for 1 year. And you can choose the payment method, credit, debit or net banking, and you have I think comfortable with the payment options. And join this Facebook group, GATE aspirants, to get regular updates from us And also we have another one, that is Telegram channel Unacademy GATE CS. So where you will get daily links or daily our classes too. We'll share the links here. And please share all these YouTube channels with your friends. If you are enjoying on this, other students who are your friends, they will be definitely getting beneficial with this all channels. So please recommend your friends to visit to learn from us. Thank you so much. And we have all subjects at one place. So this YouTube channel is for you, and we are here to guide you, and we are here to help you and try to learn as much as possible whichever is required from us. And please like the session if you are enjoying our classes, and also subscribe and share with your friends, so we will get benefited, as well as you are helping us to reach maximum students. Yeah, let's begin today's session, that is countability. And if you look at the previous classes to this countability class, and we have learned undisability and reducibility. Till the last session, we were understanding reducibility and undisability. Today is a very special topic, which is the countability. And in this countability, we are going to learn which sets are countable, which are uncountable, and what is the relationship between countability and disability. Right? Do not assume this all words are same. Everyone has a different definition here. Now let's start with a countable set and uncountable set. Guys, if you take any set, you know that the set can be finite or infinite. Mathematically, every finite set, no doubt, is countable. The problem is infinite set. In the infinite set, the some are countable and some are uncountable. Yeah, good evening, Srinivas Reddy. Right, we have countable sets and uncountable sets. When you look at the countable set, you can also realize in class diagram if you are assuming these are finite sets, these are all I am talking about infinite sets, then here countability is going to be like this. And from here to here, you can assume countable sets. But what is countable, still not discussed yet. And what are these countable sets? And every finite set is countable, so we have no problem to understand the note. Every finite set is countable. It is a trivial property. You can list out all the elements, you can count them. Every finite set is countable. You can enumerate it. But the problem is the infinite sets, only some. Some is also infinite here. Some infinite sets, not every infinite set. Some infinite sets are countable, remaining are uncountable. Then these are called as countably infinite sets. Countably infinite sets. Any infinite set is countable, then that set is called as countably infinite set. Then what is countably infinite set? For that, you should know about the bijective function definition. Let x be countably infinite set. We do not know, we want to find out. Countably infinite set. Then how can we prove that? You can prove, if you want to prove this, X is counted if and only if there is a function where that function will have bijective mapping from X to Y. This function is bijective. Bijective, another name, is one-to-one correspondence. One-to-one function, one-to-one correspondence, both are different names. Bijective, also called as one-to-one correspondence. And f is a bijective function that maps from X to Y, where Y is known countable infinite set. This is a known countably infinite set. And look at that, X is countably infinite set. Okay, just give me time, guys. That's not visible. Where Y is known countably infinite set. Then let's practice to understand what is countable. Even though definition is available, but understanding that it takes time. Because you need to know about what is to understand. So let's look at an example to understand. Very well known countable set is the natural set. Natural numbers is countable, maybe including 0 or without 0, that's okay. Natural set is countable. This is a well known countable set in the world. Well known countable set. Now I want to prove integer set. That is also a well known set, but I want to prove integer set is countable. What is integer set? That you can represent as a Z. Natural set you can represent as N. Why integer set is countable? I have to prove integer set is countable. One example, guys. If and only if I can show you that f is a function, bijective function from Z to N is bijective. Integer set is countable if and only if f is a bijective, that N or N to Z, that's okay. Yeah. Now focus on how to prove this function is bijective. And you know, Z is something like this. Okay, Z, we have, let us set, that's a domain here, and we have N, that is a codomain here. Now I have to prove f is a bijective. I have to prove that. Now this is Z and this is N, and we are mapping from Z to N and trying to show it's a bijective. For simplicity, I'm just taking N0, means including 0, so that my mapping will become easy. Without 0 also you can consider, it's your choice. Now bijective in the sense, if anybody is saying bijective, f is bijective, it means f and f inverse exist, are functions. They are functions. F is a function, f inverse is also function. Means you have to show f and f inverse, then I believe Z is countable. Then I am trying to show that I have both. F exists, F inverse also exists. Both are functions. Both are functions. Now, how do I prove it? I am going to show a mapping. Like, first I will show about F. If you ask me F of 0, I will say it is 0. Here X is equal to 0. F of X you want to compute. So F of X is equal to 0 when X is 0. When X is 0. So I am trying to worry about here X is there. Here X is there and what it maps here. I am trying to find out what is F of X. What is F of X? So I am trying to map what is F of X. If X is 0, then F of 0 is equal to 0. Now I am trying to find out F of X only, guys. F of X is equal to, now look at what I am going to map. 0 you map to 0. Now onwards I will do one thing. 1 I map to 1. 2 minus 1 I am going to map to 2. And 2 map to 3. But minus 2 is mapped to 4. And 3 map to 5. And minus 3 are mapped to 6. And similarly, when you look at Z, the negative number side and positive number side both are able to map to some element of natural set. Definitely there is a one-to-one correspondence. If I ask what is minus 3, you will say that minus 3 maps to 6. And what 6 inverse? You will say it is minus 3. And this is F inverse. Both are actually one-to-one correspondence. Means minus 3 in Z is same as 6 in N0. That means in the domain minus 3 also called as the 6 in codomain. Is it clear? So that is called as one-to-one correspondence. For that there is a mapping. You may have a program, you may have a logic, but there is a mapping. Yeah. So F of X. Now look at X. You have both positive and negative. When X is positive, when X is equal to positive, what F of X is going to map? Just look at, guys. I'm looking for positive only now. Like 1 maps to 1 and 2 maps to 3 and 3 maps to 5. What is the relationship between, if this is X, then what is it? It is 2x minus 1. X maps to 2x minus 1. So F of X is going to be 2x minus 1. Come on, everyone, guys. Yeah. And F of X, I can have 3 different mappings, but they are unique. They are unique in this mapping. And when it is X is negative, what kind of mapping is there here? Like minus 3 maps to, okay, first we'll start from minus 1. Minus 1 maps to, you have minus 1 maps to 2. Look at that. Minus 2 maps to, you have 4. And what is the relation we have? If this is X and indirectly this one, minus 2x will be minus 2x. If F exists, no doubt here we can also understand F inverse, because this function is already bijective. In the bijective, F inverse always exists. F is invertible. You can say that F is inverse function because F is already bijective. Now, how do you compute that inverse? Are you in the inverse? You can say that same way, just different way. Even the mappings are same, but inverse slightly different. How do you do that? Now you need to look for reverse mapping. N is there and Z is there. At 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on. And 0 we are mapping to 0. So now inverse, this is F inverse. F inverse we will map this way. And who came to 1? That 1 actually came to 1. Now it inverse. And minus 1 that went to 2. Now 2 will come to minus 1. And 2, that 3 comes to 2. And 4 goes to minus 2. And so on. And so on. Then inverse we are trying to compute. Here if it is x. Here if it is x. Then what is F inverse of x here? Now x is the element of the natural set. Previously x was element of integer set. Right? Now how to compute that? Now look at here two things. Odd and even. F inverse of x is equal to something will come if x is even. If x is even, then what is F inverse of x? Just look at only even numbers. 0, 2, 4 and then 6. That 4 will become minus 2. Then how do you get that? It is equal to minus x by 2. If f is minus 2x, its inverse has to be minus x by 2 only. And equal to, when x is odd, of course minus 0 is 0. 0 no need to speak, automatically 0. Odd number. And focus on 1 has to be 1, but 3 has to be 2, and 5 has to be 3. How to get that? And remember, f of x is equal to, we got to f, and if you want f inverse of x, then x plus 1 by 2 comes. X plus 1 by 2. If you have calculated inverse functions, then you can use that method to compute inverse too. But you can use numbers to understand the inverse mapping also. That means f exists, f inverse exists, so f is bijective. Or whenever I say f is bijective, then they must exist. Okay, this is why we say Z is also countable, and Z is countably infinite set. Is it clear, guys? N we know is countably infinite set. CIS means countably infinite set. And what about 2Z is also countably infinite set, and simply you can say countable. Simply you say countable. Just I am saying it's infinite set also. And 3, guys, not only this, even set. Even set means 2n. 2n is also countable. And odd set means 2n plus 1. If you want to include 0, take 0 also. 2n plus 1 or minus 1. So if I assume 0 along with 0, then plus 1 is enough. If you don't have a 0, then you must start with 2n minus 1. Like similarly, you have rational set of rational numbers like p by q form, and prime set, and everywhere mapping might be difficult, but these all are countable sets. All are countable. These all are countable sets. Then who is uncountable? That we are going to break slowly. Yeah. Guys, if you are watching this video, one request to everyone, please like this session. Right? Please like this session. Yeah, thank you so much. What is uncountable set? Guys, infinite set is 2 types. Infinite set are 2 types. Some are countable, some are uncountable. Which sets are uncountable? That whichever the set which is not having bijective mapping with any countable set. Example, uncountable set is also called as not countable. Examples, you can say set of, very easy one first, real numbers is a very famous set which is uncountable. Why set of real numbers is uncountable? Basically, you cannot enumerate the real numbers, because if you are looking for 0, 1, 2, minus 1. Do you know how many numbers are there in between 0 and 1? 0 and minus 1? Here already infinite numbers, but you cannot write all of them. You cannot write all of them, like 0.0000. The number itself never ends. Number itself never ends. Who is the next number? Who is the next number to 0? You can't write it all. This is not enumerable at all. So how can you map this number to countable set? Right? So it's going to be very, very difficult to understand real numbers, every real number in the real set. Okay, it's not going to be easy. And we have so many numbers here. In between 0 and 1, infinite real numbers are there. Okay, set of real numbers is well-known uncountable set. And you want examples? Real set is uncountable. And not only that, the set of real numbers between any two different numbers you can take in the world. Set of real numbers in between 0 and 1. Here itself you cannot 0, 1. In between these two numbers you cannot count them, you cannot enumerate them. 3. Set of irrational numbers, rational numbers you can do, there is the logic. I am not explaining here, but you can try, you can find out. Some numbers is also uncountable. And apart from this, if you try to say power set of any countably infinite set, power set of natural set, like you can say 2 power n, or you can say power set of n, right? Power set of natural set you can represent many ways. 2 power n or power set of n, p of n. This is also uncountable. And power set of integer set, and power set of rational set, power set of even set, power set of odd set, power set of prime set. These all are uncountable. Right? So this is the main relation between the countable and uncountable. And there are some facts are there you might study in discrete mathematics, like if there are 2 countable sets, union of 2 countable sets is also countable. We have many relations. Before going to compare with, before going a comparison with desirability, I'm just saying that. If suppose x and y are countable sets, then you can say that x union y is countable. X intersection y is countable. Every subset of x is countable. Similarly, every subset of y also. And even you do the Cartesian product, x and y, you can do Cartesian product, is also countable set. But when you are talking about power set of x, need not be countable. It is countable if x is the finite, but I didn't tell you finite or infinite. P of x is countable if x is finite. P of that power set of x is uncountable if x is infinite. If x is infinite. So power set of x can be countable, can be uncountable, but that is decided by what is x. Yeah. So these are the various points that may help during the exam, either in discrete maths or in aptitude or in TOC. What is the relationship between countability and decidability? What is the relationship, guys? I'm waiting for many likes, but I'm not able to see the likes. Please keep liking the session, guys, which is very important, that you know the content that we are delivering on this channel is fantastic and is definitely which is unique and really helps you in preparing exam, right? All our educators are coming for you, and we are here for you, and we only expect from you one like, right? If you are enjoying much, you can also share these links with your friends, and you can tag us by posting on Facebook and subscribe, and also to subscribe this channel. Yeah, thank you so much. Yeah, please do that. Yeah. Now, countability versus decidability. Let me talk about from the language. Here I am talking about languages, guys. In mathematically, we use a name the set, but when it comes to the theory of computation, the better word is language, because we define over alphabet. Language over any sigma I am talking about. We have finite language, that means finite set, and we have infinite set. Now here onwards, we will consider different way. Every finite is what? Regular. So definitely you can say this is decidable, and every decidable you can say countable, no doubt about it. Look at how I convert from one word to other word. Every finite I can say regular, but regular don't say finite. That may or may not. So one direction is always true. An infinite language, I'll focus on mainly that three words that we have discussed in the undecidability. Some are decidable, which are infinite, it's okay. And some are, all the finite languages are decidable, but infinite, everybody is not decidable, remember. And some are RE but not decidable, that is SD and UD. What is another name? This one, semi-decidable but UD, but not UD, SD but not UD, sorry. SD but not D. How do you write it? SD but UD. Yeah, sometimes even I confuse. Not D, not decidable means undecidable. SD but UD. Or you can say SD but not decidable. Third, not RE. You can say not SD. Not semi-decidable. Now, which are countable here? And look at, let me write this one. Countable. Decidable is countable. Who are going to come as countable? This decidable is always countable. Even it is not decidable, still it is countable. Even it is not real, there are two types here. There are two types here. Some are uncountable, some are countable. Look at that, how you require to relate the countability and decidability concept. I can't say that every countable is decidable. Countable may be decidable, may be undecidable. Right? Carefully use these words when you are comparing countability and decidability. And of course, you require a lot of examples to understand. It's not easy just by looking at this relation. There are plenty of examples in each class here, right? So I want you to remember using the class diagram. I can help you to remember this if you want. So I'm assuming these are so many names are there. I'm planning to keep the names properly. Okay, let me use these names here up to here. Okay. Okay, let's look at from here to here. I'm assuming from here to here. I'm assuming recursively enumerable. From here to here, I am assuming recursively enumerable. This is all recursively enumerable problems languages. There is semi-decidable languages. And here there is one more special class that you have. From here to here, you know the name that is decidable, that is recursive languages. Decidable languages means recursive languages. All recursives, and you know this name. From here to here, that is RE, but not recursive languages. They are also REs, but they are not recursive. They are not recursive languages. And what are these languages, guys? What are these languages? From here to here, from here to here, the languages are not REs. Not REs. All not REs comes here. Now, when it comes to countability, the countability languages that begin from here, they will come to the middle of somewhere, not REs. And here the class is divided like this. And here these languages are countable languages, are countable sets, you can say. These are uncountable sets, are uncountable languages. So you can put a barrier here. And only what you require, you need to connect well here, which languages are countable, which are uncountable, right? Which are recursively enumerable, which are not recursively enumerable. And remember one relation that you may confuse, not recursively enumerable. Don't say uncountable. Even I did mistakes in the past, and I am correcting myself. That is not recursively enumerable. Languages, some are countable, some are uncountable. I will tell you one example to understand. That is here one language I am writing, one example. Let me write separately. Suppose I am writing a set, that is set of Turing machines, where the language of TM let me write, where W accepted by TM. W is given to you. W is given to you. And even you don't know that W not accepted by TM. So this is definitely is what? Recursively enumerable but not recursive problem. It is one of the language here. Here it stays here. I'm numbering it, guys. It states here. Let's say L1. So L1 I'm saying here L1. But do you know where is that L2, which is L1 complement? That is TM such that W not accepted by, W is given, remember that. Not accepted by TM. It is straight away not RE. Straight away not RE. But where it stands, is it countable or uncountable? Guys, it is countable. It is countable. It will not go uncountable. The reason is you can count it. You can count it some other way. How you can count? That you can say set of all TMs, because this is countable set, minus L1. L1 is set of all Turing machines. Both are countable. Countable minus countable is countable only. I am trying to do some other way. Countable set minus countable set has to be countable. Even though it is not RE, it is countable, guys. So this is a very famous language where L1 and L1 complement both are countable sets. But there are languages which are uncountable. There are languages which are uncountable. Where that I can tell you something where you have equivalents, like, let me write L3. I'm writing for L3, guys. Okay, let me take one example, L3. It's a very special language. Suppose I want Turing machine 1, Turing machine 2, I want to collect from the given input, where equivalents I am checking. L of TM1 equal to L of TM2. And this problem is not RE. We know that. That's okay. It is undesirable, but it is not RE. And iski complement be not RE onge. But both will stand as uncountable here. But I'm not going to talk about complement here. I'm talking about what is L3. L3 is also uncountable set. Because there is no way to understand this problem mapping to somebody. You can't. There's no way to prove this is countability. This is uncountable set. And that L3 comes here. You want to collect set of all pairs where each pair has 2 Turing machines which accept same language. That problem is uncountable set. Not only this, you have so many other problems too, like sigma is always, let's say, equal to AB. Assume that this is given to you. Any finite set, or you can assume any finite set. Sigma is alphabet. Let's say sigma is alphabet. That is a finite alphabet. Now I'm asking the question. This is the given to you. Question 1. Sigma, is it countable? It is a finite, so countable, no doubt. 2. Sigma star, that is a regular language, definitely decidable, so definitely countable. And 3. If I say 2 power sigma is also countable. Why? Because sigma is countable, so power set of sigma also countable. But 4th, 2 power sigma star means power set of sigma star. This is uncountable. It is basically called as language of languages. The first sigma is called as what? language only, it is also language, or you can call set, but this is a language of symbols. And what is sigma star? It is also a language, but language of all strings. But what is 2 power sigma star? It is also a language, but language of languages over the same sigma. Language of symbols is countable. Language of all strings is countable. All, remember, language of all languages is uncountable. Okay. Yeah, this is countability versus decidability, guys. Today I will help you to understand what is the countable set, what is uncountable set, how they are related with the decidable set, and how they are related with RE but not recursive and not RE. And remember here, every decidable is countable, every RE but not recursive is countable, but not RE. Some are countable and some are uncountable. There are 2 types of not REs, everyone. So this is what we have learned today, and I think by today we have completed the entire syllabus which is required for most of the exams like GATE exam and other exams too. But one topic that I wanted to discuss, but that I will look at, if you want it, you can come to Unacademy, that is complexity theory, which is out of syllabus in the GATE, but other exams this may be required. You can catch me on Unacademy and I will take the sessions on Unacademy. You can attend those sessions if anybody required the complexity theory or complexity classes like PNP and NPR and so on, right? So I hope you enjoyed my classes in TOC, and from tomorrow you will have a surprise that new course is going to begin, and TOC is completed by today, but we will have is completed now, and we will do every Saturday and Sunday. Do not forget, we will have a marathon sessions, practice sessions on TOC. So please attend these practice sessions to improve your theoretical concepts and to save your time in the exam. Whenever there is any question, you need to interpret very quickly. So you require these practice sessions to build your concepts effectively. Okay guys, thank you so much for attending all my sessions, and whenever you need my support, I'm always there for you, and please follow me and do not forget to like this session. This is my profile on Unacademy. Please visit here and I will be waiting for you, and please attend my classes too there. And these are my usual regular classes like 7:30, 9 a.m. and 11 a.m. is a plus course, and 1 p.m., 2 p.m. and also sometimes 3 p.m. and 4:30, 7, 9. You can catch me all free classes, and 95% of my classes are free sessions, and you can catch me anytime. But whenever you wanted to learn from us, not only from me, from whole Unacademy, you can take the subscription. Use the referral code DEVA10. This is our team that we are trying to help you all the time on this channel to learn something. But use the DEVALIVE if you are coming to Unacademy. If you want to take the subscription, really we are there to help you, not alone. I'm not alone. We are as a team, and entire Unacademy is waiting for you. Please take the subscription if you want to learn systematically, right? Anyhow, we are always there, whether you come to YouTube channel or when you come to Unacademy. But you will see the changes, you will see the difference if you are taking the subscription on Unacademy. So like the session at the end and subscribe. Also share with your friends, and thank you so much for attending all my classes. Yeah. All right. Thank you Rishikesh. Thank you Satyajit. Thank you Hiren. And thank you Srinivas. That all of you are supported from the beginning to complete this course, and you are having the doubt whether we complete the course or not. But once we are dedicated on this channel, Maybe once in a while we may not take the class, but we will complete the course by before the exam. Remember that. So please follow us, and also share our classes to your friends so that they can also continue on this channel to learn they can learn from us. And thank you so much, and take care. Bye bye. See you tomorrow with new course, and you will have announcement for tomorrow course. Thank you. Bye bye.